Hey guys, how's it going? Welcome back to part 2 of getting started with NumPy. In the last tutorial, we have seen how you can create an array using NumPy. In this tutorial, we will see how you can slice and dice this whole NumPy array to get your desired output by using index. And that's what we call indexing in NumPy. So without any further delay, let's get started. An array indexing refers to any use of the square bracket to index the array values. For example, if you have an array called A and you want to subset this array, you can do that by using this square bracket, and you can pass all your index within this square bracket. The output of this indexing could be a scalar value, or it could be an array of different shape and length, which we will see when we will talk about the examples. There are many options indeed available for indexing, which gives NumPy a great power. But with the power comes some complexity and potentially room for some confusion. And in this section, we will try to talk about all these options available in NumPy for indexing, as well as all the issues related to indexing. Single element indexing is applicable for 1D array, or in the other word, array with n attribute as a value 1. It works exactly like other standard Python sequences like list and tuples, and likewise list and tuple, it starts with 0 and also accept negative index, which we will see in a second. So let's first create a NumPy array A using NumPy a range function. A range, then I will pass 10 as an argument here. That means it will create an array A which starts from 0 till 10 but not including 10. That means this array will have 10 elements within it which start from 0 to 9. Okay, and let's say somebody asked you grab the fifth indexed or sixth element, which is this one. This is the fifth index because Python index starts from 0. So that means if you wish to grab the sixth element, you have to pass the index number 5 here. So to grab that, in order to grab the sixth element here, you can do that by using the square bracket, and you can pass the index within the square bracket, which is 5 in this case. And if you run this one, you will get the scalar value, even though you are actually subsetting the NumPy array, but here you are getting as a scalar output. Okay, because you only pass one element here, one index here. If you wish to grab multiple elements, you can do that by using colon. Okay, so let's say you wish to grab second to sixth element. So second to sixth element. Now if I will just go ahead and run it, you will see you get from second till sixth element. So 2, 3, 4, 5. But why 6 is not printed here? Because whatever value you will pass after this colon will be not included as an output while doing the subset. And this is true for list and tuple as well. Okay, list and tuples indexing as well. Okay, now though we know how this colon works, and let me first write it down here. Now what it basically will do, I'm asking Python to start from 0th element or 0th index, sorry, not 0th element, but 0th index. It is same thing as putting 0 here, and move till 8th index, and grab exclusively every third item, grab exclusively every third elements within this array. So if you just run it, you will see it starts from 0, then move 3 step and grab 3 here, then move 3 step again, grab 6 here, then the 8th index is 9 here. So it should print 9 here, but sorry, the 8th index is 8 here. So even though I pass 9 here, the same rule applied here, you will get only 0, 3, 6 here, because even though after 6 3 step, if you move 3 step, you should reach to 9, but here as you passing this 9 after this colon, that means the index number 9 will not included here as output. So if you wish to grab the ninth element as well, so you can put up 10 or something, then you will get 9 as output. Cool. So now though we know how this positive index work, let me show you how this negative index works. So if I will put a, then within the square bracket I will pass -1, so it will grab the last item, which is 9 in this case. And if somebody asked you to uh, grab the third position element from the right till the last position, but not including the last one, so what you can do here, you can say -3. So from the -3 index, move to -1, and as we are passing -1 index after this colon, it will be not included as the output. So you will only get 7 and 8 as the output here. Cool. Similarly, what we have seen for the positive index, you can also do the similar thing for negative index as well for 2 colon here. Now what it basically will do, it will reverse the order of this array. So if you see, let me maximize this thing, and here you see the order is just reverse as compared to the original array A. NumPy array can be indexed with other arrays or any other sequence-like object that can be converted into an array, such as list and tuples. Oh, tuple is an exception, which we will not cover in this part, but I will send you or I will give you the link to this further reading material. You can go by yourself, okay? But essentially, you can index any NumPy array by using another NumPy array, but I will use list here, which is again a sequence in Python. So here I will say 4, 8, and 1. I will put this value here. Now instead of passing any index within this square bracket, what I will do, I will pass this sequence like object my list here, and when I will run this one, you will see, oops, there is some problem here, my list, oops, there's a lot of spelling mistake. So if I will change it and run it again, you will see it grabbed the fifth element, which is 4 here, then the ninth element, which is 8 here, and the one element, the second element, which is 1 here, because we are passing 4, 8, and 1 as an index. So now though we know how to index a one-dimensional array, let's see how this multi-dimensional array could indexing could work. And in multi-dimensional array, we can pass index for every axis. So let's create a two-dimension array, and things are more complicated, complex as compared to one-dimensional array. So let's see some of the example and try to understand how this thing works. So let's first create a NumPy array of two dimension and call it as A by using this NumPy A range function. And as of now, I will put 35 here. That means I want to create a NumPy array with 35 element within it, which start from 0 to 34. Okay. And I know we haven't talked about this specific function as of now, but what it basically will do, it will grab this array with this 35 element and reshape into 5 rows and 7 column matrix. And we will talk about this thing in more detail when we will reach to this array manipulation in the next tutorial. So let me first print this thing out, then you will see how this thing works. You know, it starts from 0 to 34 and it has 5 rows and 7 columns. Cool. Now let's say we want to grab the fourth row and fifth column items. So which I can do that by passing here fourth row. That means I'm interested in the third index. Okay, and we have discussed we can have index for each axis, and here we have two axes because a dot shape would be 2 here, the attribute shape it would be 2 here. So here we can pass that by the separate index by using this comma. So for the column index, we are interested in the fifth row, fifth column, that means fourth index column. So if I will just go ahead and run it, oh, I need to close this thing by using the square bracket. Now if I will just go ahead and run it, you will see you get a 25 as output. And to illustrate this thing in more detail, I have created this visualization. So row will be the red one, the column would be the yellow one, and we always interested in the intersection, which is 25 in this case. Cool. Now let's see the another example and let's grab multiple items. So let me go to the Python shell here, Python file, and here I can say 0 till 3, and then here it's 1 2 3. So what I'm saying to Python, that grab from 0th element till 0th indexed to third index, but not including the third index, from the row side, and from the column side, start from the first index, move till the third index column, but not include the third index in as output. Now if I will just go ahead and run it, you will get to 1 2 8 9 and 15 16 as an output. And again, to demonstrate you visually, this is what happening. So 0 to till the second index, and from the column side, first till the second index, because 3 here which we are passing after this colon will not include it as output. Okay, wonderful. Now let's say we want to, let me first write it down here. It's say 0 here, then I'm saying 3 here, so basically 3 using 2 colons. Okay, now what it basically will do, as you can guess it properly, that it from the row side it will start from 0 and move to the till the end and grab every exclusively third rows from it. And similarly, from the column side, it will start from the first index and move till the sixth index, but not including the sixth index, and grab exclusively every third column. Now, if I will just go ahead and run it, you will get this thing as output. And again, to show you what happened in the background, that here I'm saying 0, then move 3 step and grab this thing, which is the next one. Similarly, it's from the column side, it starts from the first yellow bar, because it starts from the one index or one index column, which is the second column. Then then move to the next 3 step and grab the next column, and you will always get the intersection. So that's why you get 1 4 20, 22 and 25 as an output here. Okay, the last example, and it's a bit difficult as compared to rest of the example which we have talked about as of now, but let me try. So let's say we want to create this subset of A by using this index, and we don't want to use index as it is, but index number as it is, but rather we will pass the sequence like object which we have talked about earlier as an index part in the row and column in the both sides. So here I will say np array uh, uh, array, and let me copy this one and paste it here. And NumPy array is again a sequence like object, so that's why we can pass this thing. And here I will pass, let's say 0 1 and 2, and for the row side I will pass 0 2 and 4. So it's absolutely fine. But if I will just go ahead and run it, this syntax is absolutely fine. So if I will just go ahead and run it, you will see, oops, there is an error. NP array. Oops, I forgot to put the square bracket here. So that's why it's throwing me the error. Now let me save it and run it. Now you get 0, 15, 30 as output. Why? Why you get like 1D array as output? Now to explain this one, let me tell you, there is an exception when you put index as an array here, and if this if you have index array for each of these axes, so here we have index for the row axis and index for the column axis here, and if both of this index which we are passing using the sequence is of same shape, which is 3 here, then it will just behave differently. So it will grab the 0th indexed row and 0th column, mm, 0th column in 0th indexed column item, that means first row, first column. Then it will go and grab the third row and the second column. Similarly, last item it will grab the fifth row and the third column. Now to illustrate this one in more detail, so I have created this graphical this visualization. So it will grab 0, 15 and 13 as item. So you have to remember this thing. So if the index array have matching shape and there is an index array for each of the dimension, then only you will get this kind of output. So we could able to do the indexing by using a Boolean array as well, but this thing is treated differently as compared to the rest of the methods, and which we will see in a second. But you have to remember one thing about Boolean array indexing. This index which we will pass as a Boolean thing should have the same shape as with the array. So here I have created this NumPy array A using this aRange function. That means now I have created a NumPy array which starts from 0 to 9. Now I know we haven't talked about this operation as of now, but what it basically this operation will do, it will grab every element of this NumPy array A and compare it with 5. And if it is greater than 5, you will get the return as a true. If it is less than 5, you will get the return as false. And whatever it return, I want to save it in another variable called condition, or in short con. So this is what we call element wise operation. We will see in more detail when we will reach to that, but let me just show you what basically it will do. It will create a Boolean array with if the element is greater than 5, then it will say true. If it is less than 5, it will say false. Okay, and both of this array as well as this Boolean array which we derive out of this normal array has the same length 10, which is 10 in this case. Now what I can do here, I will say print, I will do the subset by using this Boolean array. So I will pass this thing within this square bracket, and when I do that, you will see you will get 4 things as output. That means each of this element within this Boolean array compared with the array, and if it is false, it will just ignore that item within the actual array, and if it is true, it will grab those items, which is 6, 7, 8, 9 in this case. So that's all for today, and in the next tutorial we will see how you can do the manipulation using NumPy array. If you have any question or comments regarding this video, please feel free to drop your comment in the comment section, or else thanks for watching. Thanks for all your likes and subscription. Until next time, cheers.